Hi friends, welcome to the channel RS Junction. Today in this video tutorial we are going to write a program which will ask to input the value of n and x and then to print the sum of the series as shown in the next slide. Okay, so let's get started. Now on the screen you can see that there are four series mentioned. Inputs are x and n. You can see where they are mentioned in the terms of the series, and we have to print the sum of the series. Okay, so basically here we are going to solve the mathematical problem through Python programming, and the IDE that we are going to use is our Pycharm. Okay, so let's get started. Once you open Pycharm, we can go to new project. So we have to mention the name of the project, which I'm going to mention sum of series. Then the location, you can choose wherever you want it to be saved in your computer. Then I think rest all is correct. I have already chosen the Python version. 3.10 is detected, which is fine for me. We are going to hit create. Here you can see that we have a project sum of series at this location. Okay, so now right click it, create a new Python file. I'm going to name it as series 1. Hit enter. Okay, now we are going to write the code. So now first input the numbers. So I'll write the comment as enter the inputs. So n equal to input. Please enter the value of n as a positive integer. Then x equal to, we know that these two inputs are required to generate the terms of the series, and then we have to add all those terms in the series. Input, yeah, and now I'm gonna copy this. The value of x. Now what will be the output? The sum of all the terms, okay, of the series. So we know that we are working on this series. The first one, 1 plus x square plus x cube plus x to the power of 4 up to n. Okay, and this n will be the input and also the x will be the input. Okay, so here let's take a output variable. Okay, so what will be the output variable? Initialize the output variable as sum. So sum equal to 0. Now what are we going to do? So, and let's, for our convenience, let's copy this and paste it here. What we have to generate? We have to generate the sum of all the terms in the following series. Okay, yeah. Yeah, so this is our series. Now yeah, so since it's a series, we are going to make use of the for loop. Okay, know that for I in range function I'm gonna use. Okay, so you can see that the logic that I'm using is that there are how many terms in this series. Suppose the value of n is 4. Okay, so how many series and the terms will be there in the series? 5. Okay, we know that the range function starts with we can start with any number, but here we are going to start with 0 and write n plus 1. Okay, because so now what will happen? Now what will happen is that the variable I will take the values starting from 0 going up to n. We are writing n plus 1 because we all know that the range function indexes like it generates the range function generates the integer values from this 0 up to n. It will subtract 1 from the second term mentioned in this function range. Okay, this is a work of the range function. So that's why I have added 1 to n in the second term of the range function. Now here we are going to use the power function. So sum is equal to sum plus power. Now you can see that it's suggesting a lot of things. So basically first will be the base, okay, and second is the exponent. We know from our mathematics, right? So base, what is the base? Base will be the value x, and what we are in asking for to the user to input, and the exponent will be I. Okay, and that's it, we are done. Then we are going to come out of the loop and print sum of the series is equal to sum. Yeah, this is it. Now we can execute it from this icon here, run in the Pycharm. Please enter the value of n as a positive integer. So what are we going to input? Let's enter 4. And what will be the, yeah, let's enter the value of x as 2. So it's giving the error. What is the error? Error is that yeah, it can only concatenate. Okay, so we have done a mistake here. We know that the input function returns a string, not integer, but we are going to handle integers, so we are going to typecast it to int. Yeah, this is the way. So now let's run it. Enter 4, 2 as x. The sum of the series is 31. Now we are supposed to cross verify it by that whether our program is working fine or not through our mathematical calculation. So let's do that. Let's open a notepad. Yeah. So here we are going to actually calculate it. Okay. So 1 plus, what is the value of first? Let's enter first the values. N we entered as 4. X we entered as 2. Okay. Yeah. I'm going to just zoom it. Yeah. So n we entered as 4. X we entered as 2. And what was the output that we have got? 31. Let's verify whether it's correct or not correct. So 1 plus, and what is the series that we are going to we want the output of this is a series. Okay, is equal to what? So now 1, let's substitute it. 2 plus 2 to the power of 2, then 2 to the power of 3, then 2 to the power of 4, and that's it. Let's calculate it. So it's 1 plus 2 is 3, then plus, or we can say that like this, 1 plus 2 plus 4 plus 8 plus 16, which is equal to, yeah, if you want we can calculate it through calculator, or you can do it in your mind. It's 1 plus 2 plus 4 plus 8 plus 16, which is equal to 31. And that's what exactly what we have got here. The sum of the series is 31. So that means our program is working fine. Let's try with some other number. Okay, so we have to run, for that we have to run this program once again and enter the value of, let's say, 9, n as 9. So how many terms will be generated? 10. And then positive integer as, let's say, 3. So output is 29,524. And are we going to verify it? Yes, we are going to verify it. 1 plus 3 plus 3 to the power of 2 plus 3 to the power of 3, 3 to the power of 4 plus 3 to the power of 5 plus 3 to the power of 6 plus 3 to the power of 7, 3 to the power of 8. And what is our value of n? It's 9. So it's 3 to the power of 9, and that's it. We are going to calculate it. 29524. 29524. Let's see. 29524. So our program is working perfectly fine. Now let's get started with the second series. Second series is this one, and we can see that what is the difference between the first and second series is only the signs, that the terms are having alternately, they switch the signs between plus and minus. Okay, so let's code it. First we are going to, so and now I'm going to go a little bit faster, and I'm also going to show you how we can reuse the code. I'm going to, I've done alt control A, control C, and then control V for paste. Now these things, these inputs are the same, like these two statements are correct, will remain the same, because we just need to change the logic here. Okay, we are going to change the logic here. What is the logic? So here, let's delete this. So what is the logic here? How we will generate the terms and add? Addition, we can do sum equal to sum plus. Then how we are going to generate the term? So the logic that I've used here is that if you take the base number as -1, take the integer -1. Okay, -1, and this is a base, and if you multiply it with a number, like if you multiply it with a 0, you get a 0. If you multiply it with 1, you get a -1. Whatever you multiply, it changes the sign of the number. Okay, so basically I'm going to use a power function again. Base will be -1 and -1 comma I, and then multiply it with power of, yeah, how we have generated the term earlier, right? Here, x comma I, x comma I, and that's it, we are done. So let's run it. Enter the positive integer as 4, n as n equal to 4, x equal to 2. The sum of the series is 11. Let's verify it. Yeah, here for your convenience I have already copied the series here. N equal to 4, x equal to 2, and this is the math calculation. So what do we get here? We get a, yeah, we get a 11. So basically the code that we have written is correct, and the logic is this. The most powerful line of the code of the whole program is this. So you can like evaluate it yourselves. Basically here we have used the power function, okay, two times. One to generate the term, and second, this is to generate the term, and this is to change the sign of the term alternatively. Okay, now let's move on to the next series. Next series is this one. This is the next series. So basically what is the observation here? The first term, the second term. Second means two. Second, you can see that how they have used the terms. So what we can do is, it's all a matter of observation. Okay, so what we are going to do is new Python file series 3, and then we are going to copy our code from here to here. And now the only difference that I can see here, first of all, let's mention our series here. Generate the sum of all the terms. What is the series? This is my series. Yeah. Now, here we can. It's very easy. This is sum plus, yeah, power of x comma I. X is the base, I is the exponent. But there is one difference here in the range function. Here we are going to start, the starting term will be 1 and the ending will be n plus 1. So now what it will generate? It will generate the values like 1, 2, 3, so on up to n. N is whatever number we are going to input. So our range function will generate, range function will generate values in this order, values like this. Okay, range function will generate values like this, 1, 2, 3, like this up to n. So that's why we have mentioned 1 to n plus 1, because we all know that the range function like subtracts 1 from the second term, a second argument of from its second argument. Okay, yeah. So now here one more change we want to do, because this is, we have to divide by sorry, I, and that's it, we are done. Very small change and we are done. Let's execute it. 4, 2, sum is 10 point, yeah. Here we are getting a floating number because we have divided it with I, and the sum has adapted itself. It's not an integer, it's a float. Okay, and we can compare it. We can see the authenticity of the output, like whether we have got the right output or not, by doing our calculation. So this is the output 10.66. Then we can go here and do the calculation of this series, n equal to 4, x equal to 2, and then this is a calculation. This is also 10.6. That means our code is working fine. Now let's quickly move on to the next and the last series, this one. There is no difference except the denominators are all factorials of some number. Okay, so quickly we are going here, new Python file, series 4, and we are going to copy it from here. Control A, Control C, paste it, Control V, and our series has changed to this one. So let's copy it and paste it here. Yeah, you can see that it's a factorial. So what we are going to do is everything remains same except that we are going to use the factorial function. Factorial, yeah. In the denominator, it is being divided by the factorial of some number. So let's do this. Factorial of I. Yeah. And keep our cursor here. It will say that import math dot factorial, because this factorial function is a part of the module math dot factorial. So we are going to click on it, and if you go ahead, if you go scroll up and see, this line is introduced in the script which we have not written, but Pycharm, this, see the magic of Pycharm, that it has already introduced this code for us. From math import factorial, so from math library import factorial function, and we have introduced this, and now we can run it. Let's do it for 4 and 2. Sum of series is 6.0. We are going to verify it through a mathematical way. Okay, so you can see that we have entered 4, the value of n as 4 and x equal to 2, so we are getting 6. We have to verify it through our maths, and you can see this. Yes, this is I've already done for you. So it's coming as 6, so that means the code is correct. That's it, guys. Thank you for watching and keep practicing. Thank you and bye.